will be kind of neat. Okay? Triangles can be classified in two ways. They can be classified by the angles, and they can be classified by the sides. So first we're going to look at classifying triangles by angles. If a triangle has three acute angles, and acute angles are less than 90 degrees, it is said to be an acute triangle. If a triangle has at least one obtuse angle, and an obtuse angle is greater than 90 degrees, then it is an obtuse triangle. If a triangle has at least one right angle that's equal to 90 degrees, then it is a right triangle. And if it has three congruent angles, which is indicated here by this single line, single arc, it is an equiangular triangle. EQUIANGULAR. Equiangular triangle. Using this diagram right here, we're going to look at the different triangles. So if we look at triangle CDE, we would follow CDE. What type of triangle is this if we're classifying it according to the angle? It is a right triangle. That little dot is annoying me. I don't know what's making it show up there. Triangle BCE, which is this triangle right here, has an obtuse angle right up here. So this is an obtuse triangle. Triangle ABE is this triangle right here that has these three equal angles. So it is an equiangular triangle. EQUIANGULAR. EQUI, and then angular, like the angles. Triangle BDE. BDE has one obtuse angle right here, doesn't it? So it is an obtuse triangle. And triangle CFE, this one right in here, has a little acute angle, 3 acute angles, so it is an acute triangle. Triangles can also be classified by the sides. If a triangle has 3 congruent sides, and when I say congruent, they're the same, right? They're the same measure. So 3 congruent sides makes it an equilateral triangle. So instead of equiangular, it's equilateral. EQUI and then LATERAL. If a triangle has 2 congruent sides, does anybody remember what that's called? It's an isosceles triangle. And if a triangle has no congruent sides, in other words, they are all a different length, then it is a scalene triangle. When you are looking at side lengths, they're going to show you if it has one little mark across the middle, that means that all of the sides that have one little mark across the middle are the same size. Does that make sense? And if a side has 2 marks across the middle, any other sides that have 2 marks across the middle are the same size. So if we look at triangle JKM, that's the big triangle. So triangle JKM. So follow along to the letters and then complete the triangle. Does JKM have any sides that are the same length? No, it does not. So it is a scalene triangle. If we look at triangle KLN, does it have any sides that are the same length? How many sides are the same length? 2. So if it has 2 congruent sides, then it is an isosceles triangle. And then finally, we want to look at triangle JKN. Does JKN have any sides that are the same length? How many? All 3 sides are the same length, so it is an equilateral triangle. Now the directions for numbers 9, 10, 11, 12, 13, and 14 want us to classify each triangle by its angles and its sides. So number 9, if I'm classifying by its angle, what kind of triangle is this? It's a right triangle. And if I'm classifying it by its sides, it is isosceles. Number 10, if I'm classifying it by its angles, it is obtuse. And if I'm classifying it by its sides, it is scalene. Number 11, if I'm classifying it by its angles, it's what? It is. Okay, so I understand what you're saying. All the angles are acute, but they're all the same. So equiangular is a more specific classification than just acute. And if I'm classifying it by its sides, it is equilateral. Number 12, if I'm classifying it by its angles, it is acute. It does not have any obtuse angles. It only has acute angles. And if it's close, if you wonder, a sheet of notebook paper has 4 90-degree angles. Every corner is a 90-degree angle. Usually you have on any test, you have some kind of scrap paper, right? So you can always look. If you put it up next to it and this line comes below, then you know that this is an acute angle. If you put it up next to the line and then you can see the other line, then it is obtuse. Do you see that? So you can always check to see if you're curious, if you wonder. You can even put it up on your computer screen and look. Just like I just put it up on the TV. So number 12, if we're classifying it by the angles, it is acute. If we're classifying it by the sides, then it is scaling. Number 11, if we're classifying it by the angle, it is right. And if we're classifying it by the sides, then it is scaling. None of these are the same length. And again, if you don't have a ruler, some tests that you take will allow you to pull up a ruler on the screen as one of your tools. But if you don't have a ruler, you can always, if you're just trying to figure out whether it's the same length, you can again use your paper and make little marks on your paper and determine if it's the same length or not. Okay? Number 14, we know this is a 97-degree angle, so it is obtuse. And then we know that both of these sides are the same, so it is isosceles. Okay, if we're looking at all of our triangles in one big diagram, make sure that you are looking at the right triangle. Also, pay attention to your directions. This says if segment PR bisects angle SRT, so segment PR bisects angle SRT, meaning that if this angle is 30 degrees on this side, what is it on this side? 30 degrees. If it bisects it, it cuts it in half in the middle. And then it says, and U is the midpoint of segment RT. So if this is the midpoint of segment RT, and from U to R is 8 meters, how far is it from U to T? 8 meters as well, right? Then it says classify each triangle by its angles and sides. So if we're looking at triangle, we're looking at triangle UQR. So UQR. Look at this triangle. And we're looking at its angles. We have one angle that is 120 degrees. So by its angles, it's going to be what? Obtuse. And by its sides, we have two sides that are congruent. So it's going to be isosceles. Do you see how what we know is adding up about segment bisectors and things like that? Okay, so it's very important that you don't throw away your old unit papers, that you keep all of this because you may have to refer back to it. Triangle RST. Triangle R. Yeah. Okay, triangle RST. I'm going to start with Gabe. Is it obtuse, right, equiangular?
It's equiangular.
Okay. And classified according to sides, it is
Equilateral.
number 17, Jennifer. Right. And scaling. Triangle PRT. Go. What? Okay, according to its angles, it's what? Obtuse. Sorry, didn't get that part. And then isosceles. Triangle TQU, Jackson.
Equilateral.
Okay, it is equilateral. Let's look. Triangle TQU. Now this is 60 degrees. And we know that this angle right here makes a linear pair with this angle. So this one has to be 60 degrees. And what y'all don't know yet is that if these two angles are 60, this other one is also 60 because they have to add up to be 180. And I understand y'all might know that, but our curriculum hasn't introduced that.
We're not supposed.
You're not supposed to necessarily been reminded of that yet. But I'm reminding you of that. So it is equal angular as well. Okay. Triangle PQT, Carl, is what? Right and scaling. Okay, so let's talk about that. Nick says that he thought it was right, but it didn't have the box. Let's look right here. Segment ST has to be perpendicular to segment PR because we have the box on this side, don't we? And so if the box is on this side and this one is 90 because they're perpendicular, all four of them are 90. So it's also 90 on that side. Okay? Classifying triangles in the coordinate plane. If you do not have a picture of a triangle, but instead you have coordinates, you don't even have to draw it, do you? Okay? What you need to do is we're going to classify it by its sides. So we know that if 3 sides are the same, then it is an equilateral triangle. If 2 sides are the same, then it is isosceles. And if no sides are the same, then it is scales. In order to find the length of the sides, we can use the distance formula. That goes all the way back to Unit 2 or 1? Unit 2. So the distance formula is going to be the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. Are you having a seizure?
No.
You just need some energy out. So first, let's look at the distance from J to K. We've got the square root we're going to say the distance equals the square root of x sub 1, negative 7, minus a negative 9 squared, plus negative 7 minus 1 squared. Now, in order to find, if you put this with the square root in your calculator, you're going to get a decimal that's going to need rounding. So if you remember, I want you to put just this bottom in your calculator. I don't want that green. I can't see now. You do need a double parentheses. Thank you, Nick. I was just fixing to say that. Right here behind the 9, you're going to need another parentheses. So the distance from J to K is going to be the square root of something. The square root of what? 68. Now we can't know if that's a certain triangle or not, can we? We just know what the distance of that one side is. So now we're going to look at the distance from K to L. So the distance from K to L is going to be negative 9 minus a negative 1 squared plus 1 minus a negative 1 squared. So put that in your calculator and it's going to be the square root of something. Now I know it's not scaling, but it could be isosceles and it could be equilateral, right? So now I have to find the distance from J to L, that third side. So the distance from J to L is going to be the square root of negative 7 minus a negative 1 squared plus negative 7 minus a negative 1 squared. So it's going to be the square root of 72. Not just 72, the square root of 72. So now we can look at the distances of all these three sides, and we know that two of them are the same, right? Yeah. So this is an isosceles triangle. I want you to do numbers 22, 23, and 24. Virtual students, I want you to pause the video. Square root of 41, okay? And the distance from K to L? Okay. And Xander, the distance from J to L? What is it?
I got the square root of 130.
The square root of 130 is correct. Is that not what you got, Xander? So, since all three of these are different, Xander, what type of triangle is this? Scalar. Noah, what's the difference on number 23 from J to K?
I got 16.1.
Nope. I need a square root. The square root of what? See, you must have rounded to get 16.1.
I just put it straight in the calculator.
Yeah. So you need to put it straight in the calculator without the square root because it's not a perfect square.
It gives me a thing that says non-real answer.
Yes. The square root of 260. Okay, so see, what you need to put in the calculator, and you need to know how to do this, or you're not going to get the answers right. Okay, on the Bell Works or the other assessments. So in the calculator, when you're finding the distance from J to K, you're only going to put what's underneath the square root. I'm going to go over this again. It's going to be 1 minus 3 squared plus negative 13 minus 3 squared. So don't put the square root in there. Only put what's under the square root. And if you enter it just like this, you should get 260. So what I want you to do now is I want you to also figure the distance from K to L for me.
$130.
Okay, so your answer is the square root of 130. You're just not putting the square root in your calculator. Zach, what's the difference from J to L?
The square root of 130.
So since two sides are the same, what type of triangle is this? On number 24, Wattis, what did you get from the distance from J to K?
The square root of 242.
And the distance from K to L? Okay. You need me to show the work? Yeah.
Yeah, that's supposed to be calculated. Because my equation right now.
Sometimes if you miss one of those negatives, that's why I advise you to put those in parentheses.
For the next one, I got the square root of 101.
Okay.
See, I got
And then what did you get for the distance from J to L?
the square root of 101. I got the same thing for JK. And I put in all the same numbers here.
I don't know what you did wrong. Did you put this in again?
Mm-hmm.
one is also isosceles. Solving four sides with algebra. If triangle ABC is an equilateral triangle, that means that that all three sides are equal, right? Or congruent. So we can use any of these sides and set them equal to one another. So I'm going to say that 3x plus 1 is equal to 49, and I'm going to solve for x. This gives me 3x is equal to 48, or x is equal to 16. It also wants me to solve for y. So if you look at the other side, it's an expression with y in it. So I'm going to also set it equal to 49. So 18y minus 41 is equal to 49. Add 41 to both sides, and 18y is equal to 90, and y is equal to 5. So you have solved for both x and y. The next one says, if triangle RST is an equilateral triangle, so again, all sides are congruent, find x and the measure of each side. So I'm just going to pick two that look easy to me. It doesn't matter which two you use, and set them equal to one another. 12x minus 22 is equal to 10x minus 6. Subtracting 10x, that gives me 2x minus 22 is equal to negative 6. And adding 22 on both sides, 2x is equal to 16. And x is equal to 8. Now it also wants to know the measure of each side. Each side is the same, right? So it doesn't matter which one we pick. I'm going to go with the 10 because that's easier to multiply. And I'm going to say 10 times 8 minus 6 is equal to 74. And that's the measure of each side. I want you to do whatever number that is next, 3. Number 3.
So are we just assuming the first three triangles always are equal?
Don't assume, read what it says. This one does say it's equilateral. But all of them that we're doing are not going to be equilateral. Okay, all right. So make sure you're reading.
I didn't even see the word.
Are you doing number 3, Alex? Is your name Alex?
Yes.
Jason, number 3, what does x equal?
13.
X is equal to 13. So we know that MN is then equal to what? All the sides are the same. Do you have to use these to know what MN is? 27. To be honest, then NP is also equal to 27, and MP is also equal to 27.
Can I just put, like, for this one, since I was in there, saying for those two, I would have two and then like the equation.
So you're going to have to pay attention on your assessments to what it asks you for. If triangle DEF is an isosceles triangle, which DE congruent to EF, that means this side is congruent to this side. Find X and the measure of each side. So in order to find X, I'm going to put these two sides equal to one another because they are congruent. 8X minus 13 is equal to 5X plus 17. Subtracting 5x from both sides, that gives me 3x minus 13 is equal to 17. And adding 13 to both sides, 3x is equal to 30, and x is equal to 10. If x is equal to 10, then EF is going to be equal to 5 times 10 plus 17, which is 67. If EF is 67, then DE is also what? 67. But is DF 67? No. What is DF? It's going to be equal to 10 plus 21, which is 31. So I want you to do number 5. Pardon me?
Like any equipment says,
SU.
is 37.
I just wrote it wrong up there. Okay.
Good thing the sides are equal.
Good thing the sides are equal. That's right, Gabe. So my 5x minus 37 should have been down here. And then TU is x plus 11. So TU is what is equal to 23, but they're all equal to 23. Yes, Xander.
I don't know if my colleagues in my brand are turning around.
I'm sorry, no, it's talking, and I'm having a hard time hearing you.
I don't know if my colleagues in my brand are turning around, but when I read SU is 37 plus 5 times x, I can 5x plus 3. Why do
I don't know why you think that. Now, then, reverses the order of that, so your 5x comes before the 37, but it doesn't change the less to more.
So I think it's saying less, it means you need to add that much to equal, although then it's, okay, my brain just went, skipped a step.
That's okay.
You're right.
You're right.
I think I just.
Number 8 is an isosceles triangle, meaning that two sides are equal. So I'm going to say this side and this side are equal. So MK and ML. Are congruent. MK is 7x minus 15. KL, that's the bottom one, is 4x minus 5. And ML is 10x minus 42. We can't choose which two we want to set equal. We have to choose the two that are congruent, MK and ML. So we're going to say that 7x minus 15 is equal to 10x minus 42. Subtracting 7x from both sides, that gives me 3x. And adding 42 to both sides, that gives me
27.
27.
Yes.
So 9 is equal to x, or x is equal to 9. And then to find the measure of each side, so MK is going to be 7 times 9 minus 15, which is 48. No, yeah. So ML is also 48. And KL is going to be 4 times 9 minus 5, which is 31. Everybody get that right?
Yeah.
Number 9, x is equal to what?
Hey, I did not get
You did not get that far. Okay. I'll give you a few more minutes. We'll pause again. And I'll give you a few more minutes to finish 9 and 10.